We are doing part of 1.3. We've already covered a lot of things in part 3. At the very bottom of the first page in part 3 is our slope-intercept form is y equals mx plus b. What is the m? Slope. What is the b? The y-intercept. We also have gone through point-slope form. Y minus y1 equals the slope multiplied by x minus x1. And then we have also done the slope formula using two ordered pairs, which it's not written here, so I'm going to write it. Our slope formula is y2 minus y1 over x2 minus x1. So we've already covered all of that stuff. That was in section 1.3. And then we look at the next page where 1.3 changes is now we're going to look at, this is the page I forgot to put in there. Where 1.3 changes is we're going to look at real life application and what it means. Like, mean something. So, I've done a lot of the work. We're going to fill in some spaces. If you want to fill in with like a different color so it stands out, or if you just fill in your pencil, it's totally fine either way. Yeah, you couldn't really staple it in order because I messed up. Like my page 2 was sitting on my desk over here and I took everything else in there. I know, I messed up. Okay. Only mistake I'm making the whole year. Yeah, I don't. So here's a picture, and you look at this diagram, and we notice that the x-axis is time in seconds. We notice the y-axis is distance in miles. And we look at the top, and this talks about some asteroid. 2012 DA14, I assume, is its name. But it's an asteroid. So this talks about how far the asteroid is traveling in miles per second. So what I did was I found the slope. I used this form and I used our slope formula. I found the slope, and the slope is 24 over 5. And we're going to interpret that slope. Interpret means we're going to write it in words. This means it travels 24 miles every 5 minutes. Remember, when we do slope, it is the difference in y over the difference in x. So the y values in this picture are miles, and the x value would be seconds. So that's why I talk about the miles. Oh, I said minutes. I'm wrong. It's seconds. We better change that. I'm wrong. I thought that was really slow. Oh, and I didn't. That's the one I copied. All right, second mistake. Only other mistake I'm making this whole year. There we go. I'll check sometime. What we're going to do is we're going to interpret that slope, but we're not going to talk about it as every 5 seconds. We're going to talk about it per second. So when we're going to interpret that slope, we're going to kind of reduce it or divide it. So it's going to be, it travels how many miles per second? That's what we're going to interpret our slope to be. How could I take 24 miles every 5 seconds and turn that into the number of miles per second? How can I do that?
You're asking us to answer?
Yes, I'm asking you to answer me. You would use division. 4.8 miles per second. If you divide them, it makes the bottom 1. If you divide them, it makes it per 1 second. So we just divide 4.8 miles per second. Okay, that is interpreting the slope, telling us what it means for this particular situation. And then I went and I found the equation of the line. I have the equation of the line. the equation of the line is y equals 24/5. If we look at the picture or if we look at our equation, we need to interpret the y-intercept. So what is our y-intercept? If we look at the picture, it's 0, 0. That's our y-intercept. If we look at the equation, it's that plus b. There isn't a plus b, so it's 0. So at what time the asteroid is traveled how far is what we're asking for the y-intercept really here. What does the y-intercept mean for this picture? We have to talk about time and distance traveled. Think about it like an ordered pair. This is 0, 0. I'm going to talk about the x first, then I'm going to talk about the y. X is time. So what does 0 mean for time? That means it hasn't gone, like no time has passed, right? So at 0 seconds, we could say, at 0 seconds, or I don't know how else to say it, at 0 seconds, now we talk about y. What's y telling us?
Distance.
It hasn't traveled anywhere. Silly to say, but can you say it? At 0 seconds, no distance traveled. It's not always going to be 0, 0. And then the second question, or the third, or the whatever last, B question. Asteroid within 17,000 Earth in February 2013. About how long does it take the asteroid to travel that distance? So that's how close it got to Earth. How long would it take if it was going straight towards Earth to get to Earth? How are we going to find the answer? What's y represent? What does the y value represent? Miles. And the x represents time. And what are we trying to find here? And what do we know here? So we know the miles. Oops, 200. We don't know the time. So we got to solve an equation. How do I solve an equation that has a fraction in front of the x? Okay, there's two different ways. You can multiply by 5. So cancel that out. Pull out my calculator unless you want to do it all by hand. Feel free. What?
1086,000.
Oh, you told me the final answer. I'm not there
No,
yet.
not the final answer. Like if you multiply 5 and 17,000.
I just got 86,000.
Ah, shoot.
Okay, so once I multiply by 5, I get 86,000. Now I divide by 24. And it's approximately. It's not an exact answer. 1,583. We'll even give you the extra 33 seconds.
Well,
Or 0.33, I guess,
you
seconds.
say like the fraction one first, like
Sure.
okay.
So if I told you, all right, the asteroid is about to hit in 3,583 seconds,
We're screwed.
would I say it like that?
Yeah.
No, I would not. No, I would not.
Which means it's approximately an hour.
Well, let's find that out. What would I do to this number to change it into something else?
Divided by 60.
Divide by 60. Okay, if we divide that by 60, that changes it into minutes. 59.7, and it's like 2 repeating minutes. That might be closer to something I would say, or maybe you guys got under an hour. Say your goodbyes, or whatever. I don't know.
Probably.
I mean, but think about that. 17,200 miles away, and it would take an hour.
Are we just like is this like a real thing? That's not
Yeah.
or-
Yeah, right now.
No. That was in 2013.
So basically the asteroid is hit by now or
It's not hitting us.
okay.
It was
Hitting in 20
it was
days.
probably like out here going this way, you know, but it was that far away.
Oh, okay.
So if it had just gone this way a little bit,
We're screwed.
we would have been.
Well, first you.
I don't know. I don't know.
Die.
I don't know. All right. So that's what we're doing to start today. Here we go. This next one is, anybody plan on or have bought a car? If you don't pay straight up cash, you get a loan. So this is like a real life application, something you need to know. So here's information. We look at the number of payments that we make. And it does say up here it says these are monthly payments. So like 10 is 10 months. Well, he said car loans.
In general. I
Um,
love cars,
but you know, I don't want to get into a whole big discussion, but you know, if you ever want to earn, like get good credit, you have to have some sort of loan or some sort of something to get credit someday. You just got to like pay it off on time.
It's just like, if you have like so much money that you don't even know that you can buy things with cash. Like if you have like $2 million, you can buy a car with cash.
Do you just have $2 million right now?
No.
Okay. I don't know about you.
Back pocket right here.
Yeah. So most of us aren't going to go out into the real world having that amount of money.
Well, if you have that amount of money, you can get all the things.
You say all the girls.
Maybe.
Never got $2 million.
Okay, so we are doing the slope of this information. We've got number of payments. We have the balance in thousands of dollars. So where it says 18, it's not $18. It's what? $18,000. So as I did my slope, I got -3/10. What does that mean? That means I am paying and the loan is decreasing. That's why it's negative. I said the balance of the loan decreases by $3,000 every 10 payments. Okay? Every 10 payments, it's going down by $3,000. I'm here, I can fix it. It doesn't do what it did before. Okay, why am I saying 3,000 and not 3? Because this number is in thousands, right? Okay, so now I want to know how much it's going down by every payment.
No.
Well, 300, but before I say yes, you're right, it's going to go down by, what would we do? We would take this number and perhaps put it into thousands so it makes more sense. And then divide by 10. So it's going down, you're basically paying $300 a month.
Yeah,
Yeah, no, I said you were right. I was just wanting to explain how we got it. So,
Not really.
loan decreases $300 per month. So when I'm asking you to interpret the slope, it's per one of the bottom. You always have to divide it. Let's interpret the y-intercept. Now the y-intercept is like not at 0, 0. Let's interpret what the y-intercept means. Here's our y-intercept at 0, 18. What does that mean? After how many payments?
0 payments.
0 payments. The loan is $18,000. So that means you bought your car for $18,000. Maybe the car cost $20,000 and you put $2,000 down. It's just, that's what the loan is for. Okay? Maybe you couldn't pay for the whole car right away, and so you put some money down, but that's whatever the loan is. Or maybe the car is just $18,000. The equation of the line, oh gosh, I guess I meant to do that. Well, hang on, I'm going to do it real fast. No, yeah, we need it to answer the next question. So I know the slope, I just need point slope form. Oh, I know my y-intercept already. So y equals -3/10. X plus 18 is the equation of the line because I know my y-intercept. and I know my slope. So I didn't even have to do point slope form because I already knew my y-intercept from the graph. What is the remaining balance after 36 payments? So after 3 years, how much money do you still owe? So where is 36 going to go? Is that going to go in the y value or the x value? How do you know? Yeah, when you look at your table, that's where your x's
Number of
are.
payments is X.
So we're going to do negative 3/10 times 36 plus 18.
Hold. Ash.
He said, come down.
What did I get?
Hold on. Nobody answered.
Daniel, you type it in your calculator?
36 over 5, which
No.
Did you type it in your calculator?
is... Yeah. But then I got
You have to have one. What?
7.2.
I got 7.2. Well, let's interpret that. What does that mean?
That's what I got.
$7,000.2.
After 3 years, we still owe $7,200 after 3 years. You still owe $7,200. That's just for $18,000 car. All right. Yeah, but some people cannot get a house without credit.
Where did you buy the house in cash?
I'd like to know what your job is.
Why for real?
Houses are like 200.
You just said a house is 200, 300.
No, like
Thousand.
1,000. In
1,000.
reference to thousands.
Yeah.
Like usually that's what like.
I'm gonna buy myself a $200 house here.
It's gonna be this big.
It's gonna be beautiful.
Okay. Now this one I tried to go through and already write the important information, so we're just going to things. So this one we're talking about finding a venue to host prom. Where are we going to have prom? So there's this place called the Lakeside Inn, and there's some information about the Lakeside Inn. If you have 100, it costs this much. If you have 125 students, this is how much that you have to pay, and so on. There's also the Sunview Inn that just gave us an equation that says y equals 10x plus 600. So what I did was I made some ordered pairs so I could compare these two.
You should add the spin.
Yeah, I guess I could have changed the name. And then I also took the Lakeside Inn and I wrote the equation by finding the slope and doing point slope form. And I wrote the equation for the Lakeside Inn so we could also compare the equations. Okay? To do for these is we have to interpret the slope. So the slope is 12 or the slope is 10. What does that mean when we're talking about number of students being the x, the total cost being the y? Remember, slope is the change or the difference in the y's, difference in the x's. So we look right here. What is my y talking about?
The cost.
Cost. And my x's are
The number of
student. So we need to interpret our slope that has to do with cost per student. So we look at Lakeside Inn. How can we interpret the slope for Lakeside Inn? The slope is 12. What does that mean?
That means
What's the top number in the number 12? What's the top number in the number 12?
12. It's
So what's the cost? I'm pointing right here and I'm pointing right here. What's the top number?
12.
So what's the cost?
so
Per.
student.
So interpret the slope. $12 per student. How about Sunview Inn? Interpret the slope.
$10 per one student. I think. Is it?
Yeah.
Okay, yeah.
It's $10 per student to rent the venue. Now we're going to interpret the y-intercept. So we can see my y-intercept up here is 300. So 0, 300, and we look at what x stands for, and we look at what y stands for. What does 0, 300 tell us?
If there's 0 kids in like this,
Even if nobody comes to prom,
that's totally.
you still have to pay a fee just to rent the room.
Well, you made a reservation, now you have to pay.
That's your reservation fee.
That's
No, that's how places work
well,
sometimes.
understandable.
If you want to hold that room, you have to put down $300. Then per student, we're charging $12 on top of it. So if nobody comes with no students, with 0 students, room costs $300. How about Sunview Inn?
Oh, shoot, that's. It's, if you have 0 students, you have to pay $600 for the.
With 0 students, room costs $600. So, who should we go with?
Oh, shoot, this is like.
This is real life stuff.
Well, here's the thing. Which one has like more spacious and like maybe
They're exactly the same.
What?
They're identical. Which one should we go with?
Sunview.
It depends how many total
Lakeside.
students.
How many students are there?
Chris.
It depends how many total students they have.
It depends on how many total students, because I also made a table to go and compare. If you look at 200 students, Lakeside is costing more. But if you look at 100 students, Sunview is costing more. You know? So it's going to depend on the number of students that are coming. At what point will they cost the same amount? What is that one number that it wouldn't matter? Did you find it? 150 students, they would both cost $2,100. So down here, this is still the same situation, but now there's a third place, and I went and I did all the work for it already. This third place is called Maple Ridge. And Maple Ridge charges a rental fee plus $10 fee per student. The total cost is $1,900 for 140 students. So what I did was I used the slope, and I made an ordered pair, and I did point slope form, found the equation to be 10x plus 500. So how does Maple Ridge compare to the other 2 venues? It's cheaper for what? Is the room fee cheaper? Than one of them. So the room fee is $500. It costs more than Lakeside, but less than Sunview for just the room fee. But what about the charge per student? It's the exact same as Sunview. So when I graphed it, and it's kind of hard to see, I tried my best 20 times, just to make it look really good for you guys. It's hard to see. If you see over here where it says Maple Ridge, and then you see Sunview, because they both charge the same amount per student, they're parallel. Their lines are parallel. They'll never cross. But Lakeside charges more per student. It eventually goes higher. So for Sunview and Maple Ridge, when are they the same? I lied. For Lakeside and Maple Ridge, thank you for saying that. Sunview and Maple Ridge are never the same. Lakeside and Maple Ridge, when are they the same? At 100 students. Oops. 100 students. So if you have 100 students or less, you'd want to go with, which is Lakeside. But if you have more than 100 students, you're going to want to go with Maple Ridge. Okay. Graphing calculator section. Did you do regression last year on the calculators? On the calculators or not? Not last year. 2 years ago on the calculators?
When did we do that?
Yeah, we did. When we had that charge room with Miss Cohen?
Well, let's call it Google.
Okay, I'm recording, so don't say anything. If you don't have anything nice to say, don't say anything at all. What I want you to do first, we're going to pretend we're about to graph something. I want you to go to y equals, and I want you to make sure nothing's in there. So what I'm going to do is I'm going to teach you how to enter in statistics and graph a scatter plot, find the line of best fit, graph that, interpret data, all on here. This is being recorded, so you can go watch it again if you need to. And maybe you did it your freshman year, which would be even better. So what I'm going to do is, since we're talking about statistics and data, we're going to go find the button that says stat. Right here, where my fingers are, stat, and you're going to push stat. And you have to tell your calculator everything. So you have to tell your calculator the data. So we're going to enter it in edit. Edit. Now, I have some stuff in there because I must have used it last year. So if you want to clear anything that's in there, we go up to the top of the column and you hit clear, then you hit enter and it clears the column. You go up to the top, you hit clear, enter, and it clears the column and you're ready to enter. Here, we're making a scatter plot of the length of a femur compared to the height of the person. And it shows you where the femur is, and there's also a humerus on the next page. But the femur is that long bone in your leg. So we're going to type in our X column. You're just going to type in 45, enter. 32, enter. And then you'll arrow over and then type in your Y values right next to it. When you're done, you should have the same amount of values in both columns, or you type something in wrong. There is a way to do this stuff on Desmos, but I'm not going to teach that right now because you were supposed to have a calculator for class. Does anybody have the Casio and have to do it a different way? Is there anybody with a Casio in here? Maybe it's my next class. So if you're looking down here, this is step 1. Step 2, we're going to use our linear regression feature. There is a step that we need to do, perhaps, maybe, unless you did it 2 years ago and it's still turned on. You do not have to do this every single time. So there's a step we got to do this time, but you don't have to do it every time, so let's do this really fast. Don't have to do it every time. Please, we're going to click on the catalog, which is second. It says catalog, and you'll see this big list come up. And then I'm the D's, so on my alpha, like there's a D above that X to the -1. I'm going to hit that, and it's going to jump all the way to the D's. And I'm going to arrow down until I find where it says diagnostic on. We want to put diagnostic on. If you have your arrow on that, hit enter. And then enter again. And it'll say done. You never have to do that again unless you reset your calculator. You don't have to do that again. If you didn't bring your calculator today, and you're going to have to do that when you watch this video. Okay, now I just entered in all the data. We're going to go back to stat. So now we're on step 2 that says we're going to do a linear regression of this data. That means we're going to find the line of best fit, the average of the data in a line. So you go back to stat, and this time we're going to calculate. C-A-L-C, calc. We're going to arrow over to calculate. And if you look carefully, the fourth thing says lin reg, AX plus B. Linear regression is number 4. So we're going to choose number 4. Depending on your calculator, you might have to enter a bunch of times, or maybe you just have to enter once. It just depends on how old your calculator is. But I'm going to enter a bunch of times for mine. And when you are done, you should have the exact same thing I have on here unless somehow I type something in. Now I can troubleshoot. Does anybody need any help with their calculator?
Have you ever had their burger sliders? Burger sliders. Get the burger sliders.
Enter. Oh, you have it.
God, dude,
I don't know. You might not have
Why don't fall off?
You're just like getting so excited that you know when you're funny. Okay, Waffle House's sliders are amazing.
Hey, we're recording. I don't want to hear this. Okay, it says your dimensions are mismatched. Oh, you entered it L2, L3? Yeah. So we can change that, but later you're going to have to go over to fix it. So when you do your regression,
Well, we're like, say Waffle House. You would have your Waffle sliders.
but make sure you type in the right column. Okay, yeah.
Every time I ever let you walk, my face is back in the sun. I built everything. I'm talking about it. If you go to Waffle House, it has to be like 2 a.m. Like 12 o'clock. See, you go with this cute squad at like 12 o'clock.
Okay, let's go on. So this is giving us a couple pieces of information. It's giving us the equation, which you can approximate on your paper. It's using A and B instead of M and B. You can approximate it on your paper. Y equals 2.6x plus 64 maybe 65. When by the time I round it, about 65, because I round the 6, it rounds the 99 up to a 5. So that's the approximate equation. Oh, look, they have it right here. Right? It's done. Right there. Okay. And then this r squared we're not going to deal with at all, but we're going to look at just the r. And we're going to look for values of r on the next page that are close to 1, or we're going to look for things that are close to -1. And I'll show you that in a moment. Okay. Now we're going to graph this. So to graph it, you're going to first go second y equals, which is statistics plot. That's where we're going to stat plot. And you see mine says off. So I'm going to hit enter so I can turn it on. I'm going to hit enter again so that the dark highlighted part is on the word on. And then you get to choose what kind of graph, but today we're doing a scatter plot, so make sure the scatter plot is clicked. Audrey, if you did not retype in your information, you're going to have to change your X list and Y list, because mine says L1 and L2. You typed them in the wrong column. You'll have to change it to L2 and L3. Okay. But you can change that by, if you are changing it, it's like second 1 or second 2. But everybody should say L1, L2. And then the mark, that doesn't matter which mark you do. And if you have color, it does not matter what color you want to do. Okay. If I hit graph, you guys are going to go, nothing showed up. If If I hit graph, you're going to say nothing showed up. Because what is my window at right now? 10s and 10s, but what are my numbers like? Not 10s. So we can go to our window and think about and what your lowest y's might be, and what your highest x's might be, and what your highest y's might be. It's coming. Minimum, my x's, how long could the femur be? Probably 0. We can't have a negative length of a femur. What's the biggest femur on here? Is it 50? Okay, so maybe I'll make it 60. Sounds good. And then the scale is, what do you want to count by, like the little tick marks? I don't know. 5? I don't know. That doesn't really matter. If you want. Minimum for the y's. The y's are height of a person. Well, nobody's going to be negative, so we'll put 0. And then the highest on here looks like maybe 190 something, 200. And I'll count by tens. Now if I hit graph, there it is. There's my scatter plot. Okay? Okay. We are going to graph the line now on top of this. So remember we found the equation of the line? Remember we found that? Let's do that again. So to find the equation of the line, you're going to go stat, and you're going to calculate, and we were doing linear regression, number 4. And you have to have this information here if you want to have your calculator copy the equation so you don't have to type the whole thing in yourself, which is what I'm going to show you how to do. So we're going to take this information and we're going to write the equation into our y equals. Okay? So where do we want to put this information? Where do we want to put this information? Where do we want to put it? In what? We want to graph it. How do we graph something? Where do we put it? So you're going to type y equals, and it says, all right, I'm ready. Stick something in here. You're going to hit vars. Sorry, couldn't see where my finger is. Vars, V-A-R-S. I don't know what that stands for. Maybe. I don't know what VARS stands for. We are doing statistics right now, so we're going to choose 5. We want to copy an equation, so you're going to go over to EQ, and we just want a regular equation, number 1. And it'll take all those numbers you just got, the exact numbers, and stick it in Y1. So once you have that, hit graph. The steps again were vars, statistics, equation, regular EQ. I recorded this. You can go back and watch it. Graph, and there's my line of regression, my line of best fit. The last thing I want to show you what you can do here, it says estimate the height of a person whose femur is 36 centimeters long. There's 2 ways we can do this on here. There's one way you can do it by just sticking 36 in X. We can do it by hand. But there's 2 ways to do it on the calculator that are even more accurate. The first way is second trace, which is right here, second trace, which is calculate, and you're going to choose value. And this says if X equals, what do we want X to equal? 35. Oh, I think I said 36. 35. You hit enter, and down at the bottom it tells you the person will be 156.1. That's one way. And another way, especially if you want to get multiple answers, and I don't know, or maybe you want to find the X value for a certain Y value, if you go to the table, second graph, if you go to the table, you can scroll and you can jump to other numbers too, which I can show you how to jump there, but you can scroll to whatever number you want. I can go all the way to 35 if I want. Or if you just want to jump to 35, there's a button right here that says set. You do second window and just say start my table at 35. and then we go back to the table, which is second graph, and now it starts at 35, and it tells me the exact same answer. So either way, you're getting those points. This gives me all the different kinds of points that I would want as well. So I have a four-question worksheet. Oh, we didn't get to talk about this. We have 2 extra minutes, so we can talk about this. The correlation coefficient tells you how close to being that line it is. If the number, the correlation coefficient, is close to 1 or -1, then it is really close to being, those points are really close to correlating to each other. If the correlation coefficient is close to 0, that means there's no correlation whatsoever. You know, if I said the number that you were born, like the month that you were born, and the height of your body, should that correlate?
No.
It shouldn't. So probably would look like this. Okay? But if I said the length of your femur compared to your height, that should probably correlate close to a line. It's not going to be the same for everybody because we don't have the same proportions, but it's going to be close. So there's a question about how strong the correlation is on your worksheet as well. It's 4 questions. They're all graphing calculator questions. You interpret the slope, you interpret the y-intercept, and you talk about the correlation coefficient. We did not have time to go over that other worksheet, so that we will do on block day. Also on block day, we have to have our name graphed on paper so that we can do the Desmos part. I am not telling you the Desmos part if your name is not graphed on paper with the equation that we started doing last Friday. The equation for the name, remember, after our quiz. So you guys have XH. Before you see me again, you have XH. If you come ask questions about the name thing, you get help with that. Did I miss anybody with the assignment?
Wait a minute. So like, I ain't remember. Like, you say, how do we find the equation?
Let me stop this real quick.